Hi. So in the last session, we built a very basic decision tree for our bank loan problem. Okay. If some person comes to me with the properties of H, Y and L, that means he has a high income, he has a criminal record and he has a very low loan demand. So what I am going to do? I am going to start from a decision tree over here. I will go this side because his income is high, he has a criminal record this direction and he has a very low loan demand, right. So, and answer is going to be yes. So, basically at every point I will be able to take decisions. Okay. So, this decision tree will help me take decisions at every point. Now, let us try to bring some more sense into this decision tree by using some numbers, okay, by using some numbers. So, as we can see that we had used 100 data points as a training data. If among those 100 we had 20 yeses and 80 nos, okay, 20 yeses and 80 nos, okay. For someone like us who have not built a decision tree yet, okay, if some person comes to me and asks me whether I will get a loan or not, so the safest bet right now for me is to say that he will not get a loan. Why? Because the only information right now I have is that out of the 100 people that visit the bank, 80 have not got the loan. So, there are high chances that people generally do not get the loan, okay, until and unless we are able to build the decision tree or apply any other algorithm on that. The safest option is to say simply no, okay. So, what I am trying to say is that let us say I am starting from here, okay, I am starting from here. If there are 100 points, out of which 20 are yeses and 80 are no, okay. Right now I am just starting and I have not made any decision tree. So, at this point I should be predicting no for whoever visits me and asks whether I will get a loan or not. So, if at this point I have to calculate training accuracy, what would that be? What do we mean by training accuracy? That if all the 100 points, that of all the 100 people whose training data I have, if those people ask me whether I will get a loan or not, I will be predicting no for all of them 100, okay, because the only information right now I have is that out of 100, 80 people do not get the loan. That is basically bank does not give the loan very easily. So, I am just going to say no to everyone who visits me. So, from the training data people, I will be able to predict 80 of them correctly because I am going to say everyone no. So, I am going to predict 80 of them correctly and 20 of them are going to be wrong, okay, because the actual people who did not get a loan, 80 people, I will be predicting correctly for them, but the people who actually got loan, I was predicting no for them also. So, I will be making 20 errors. So, my training accuracy at this point is 80 by 100. So, what I mean to say is if I do not build a decision tree further, my starting training accuracy is going to be 80 by 100. Okay. I think this is clear. Now, let us get one step ahead. Okay. Let us get one step ahead. Now, I want to first classify on the base of income. Okay. I want to divide based on the income. Now, let us say out of the 100 people, there were 20 people who had high income, okay, they had high income. Now, out of those 20, I realized that 15 got the loan and 5 did not get the loan, right. So, this data is already available to me from the bank. So, I can see that out of 100 people, 20 were high income people, okay, and 80 were low income people. Out of those 80, 5 were yeses and 75 people did not get the loan, okay. So, after splitting based on the income, my training accuracy is going to increase a little bit. I mean, it might increase a little bit. Let us check if it does, okay. So, if I again check for those 100 people, now when those 20 people come to me, definitely I will be sending them this side, okay. As I can see that generally the people who have high income, out of those 20, 15 have got the loan, okay. If I look at the past data, that the people with high income, that is those 20 people. So, what I can say is that there are high chances that high income people generally get the loan. So, for all of those 20 people, for all of these 20 people, I am going to predict yes, I am going to predict yes. So, basically I will be making 5 errors. I will be predicting yes for all of them, but I will be making 5 errors on the people who actually did not get a loan, that is these 5 people. Similarly, from all of these 80 people who have low income, I can see that 75 actually did not get the loan. So there are higher chances that people with low income does not get a loan. So I will predict no for all of them 80. All of them 80, I am going to predict no, right? So what that means, that I will be making error on these 5 points, okay? I will be making error on these 5 points. So in total, I will be making 10 errors, 5 from here and 5 from here, right? So my training accuracy is going to be 90 by 100. Let me just explain it again. We started with 100 people, out of which 20 were yes and 80 were no, okay? First we split them on income, and then we saw that high income people there were 20 people and low income people there were 80 people. Out of those 20, 15 were yeses and 5 were no's. And out of the 80 low income people, 5 got the loan and 75 did not get the loan. So when the 20 people, the training people, the 20 people who had high income came to me, I would be predicting yes for all of them, because I know that generally the 20 people who visited the bank, generally people have been getting the loan, that 15 of them have been getting the loan, so there is higher chance of getting a loan, right? So I will be predicting yes for all of them, and hence I will be making 5 errors. And for the low income people, I know that the general trend is person does not get a loan. 75 out of 80 have never got the loan in the past, so I am going to predict no for all of these people. Whoever tells me that I have a low income, I will straight away say no, okay, because my decision tree is just based on income right now. So I am going to predict no for all of them 80, and again I will be making 5 errors. So in total I am making 10 errors, which means my training accuracy is going to be 90 by 100. So I think now you are able to understand how just by splitting on one feature, our accuracy all of a sudden went from 80 by 100 to 90 by 100. This is how decision trees basically helps us in increasing the accuracy. As we go down, we generally increase the accuracy. It might stay constant or it might increase. It never comes down, right? Yeah. So now let's try and classify our decision tree further, okay? So if I classify it further on criminal record, based on criminal record, let's say a person is a criminal and a person is not a criminal, okay? So let's say out of these 80 people with low income, 40 of them were criminals, okay? 40 of them were criminals. Out of these 40, one got a loan, maybe using his criminal power, and 39 did not get a loan. Similarly, out of these 40 people who were not criminals, 4 got the loan and 36 did not get the loan, right? Total 4 plus 1, 5, which we already know 5 people got the loan, right? So this is how we have classified it further, right? Let me classify once again. Let me do it on loan demand also. Loan demand. Let's say out of this 40, 15 people were with low loan demand, and out of those 15 people, 3 got the loan, 12 did not get the loan. Similarly, out of these 25, 1 got the loan and 24 did not get the loan, right? So this is quite a logical decision tree which we have built based on some numbers, okay? So let's say if someone comes to me with properties of L, N and H. So what we are going to do in that case? So I'll straightway say, I'll start from this L side, then I'll go towards N, then I'll go towards H. As I can see that out of 25 people who had L and H properties in the past, 24 did not get a loan. So I'm straightway going to say that you are not going to get a loan, right? Similarly, if a person comes to me with his properties like L and Y, and let's say L, so what I'm going to do, I'll go towards the L, then I'll go towards Y, then I have no further classification. I would say that out of the 40 people, 39 did not get a loan, you are also not going to get a loan, right? So this is how basically we are able to use the decision tree to predict, right? So this is how we can use decision tree for our machine learning problems, okay? So I hope this is clear. In the next session, we will look at how we basically choose the features. to split on. Okay, like you can see, okay, first I split it on income, then I split it on criminal, then I split it on loan demand. I could have also done first split on criminal, right? I could have also done first split on loan demand, and vice versa. There could have been lots of permutations. So which one exactly we have to choose, how we have to choose, that we are going to discuss in the next session. Okay, so thank you.